Hello, for this little video tutorial we're going to look at adding and subtracting polynomials. But before we jump into adding and subtracting polynomials, let's have a look at some of the definitions around polynomials. Now the first one is you need to know what a monomial is to understand what a polynomial is. A monomial is a single term. It could be a constant, like just a number, in this case -8. It could be a single variable like x or r or c. It could be the multiplication of a constant and a variable like an 8y. It can be the combination or the product, of a constant and multiple variables like in this case. So these are all considered to be monomials. Now, each monomial is another word that we use is a term. So each monomial term has a coefficient and a degree. The coefficient is the number that comes out front or in front of the variable. So in this case, the coefficient would be 6. The coefficient of this particular monomial term would be a -13. And the coefficient of this numerical term is 12. Now, what you don't see here is that this is like 12x to the 0. Remember, anything to the 0 power is 1. So this is really the same as 12 times 1. So the actual numerical coefficient here would be just a 12. The degree is the total amount of the number in the exponent position. So if you are looking at this term here, I have the c and it's to the first power. So the degree for this example would just be 1. Now here's an interesting example because I have x to the third, I have y to the first, and I have z to the third. So notice that I have a 3 and I have a 1 and a 3. When you are dealing with multiple variables, the degree is the addition or the sum of these exponents. So the degree of this example would be 7. And here for this little one here, the sneaky one, the degree of a constant is always 0. So the degree, the highest exponent, the highest sum of the exponents there would just be a 0. When I link all of these terms together, I could link them with additions, and I can link them with subtractions, and I can link them with more subtractions and more additions. When I link up all of my terms, I get what is called a polynomial. So a polynomial basically means many terms. Here is a monomial term, here is a monomial term, and here is a monomial term. I have 3 terms linked together, and we call it a trinomial. A binomial is if there's only 2 terms, but this case I have 3 terms linked together, and we call it a trinomial. Now if I look at the degree of my first term, it's a 4. I look at the degree of my second term, and I add them and I get a 5. I add the exponents and I get a 5. The degree of my third term here is a 1 and a 1, which is a 2. When you are asked for the degree of the entire polynomial, what you do is you find the highest degree, and that's the degree of the whole polynomial. So now we're ready to add and subtract polynomials. The way we do that is we're going to look at each individual monomial, and we're going to look and see if there are any matching monomials. And when I say matching, I mean that they need to have the same last name. They need to have the same back end portion. They need to have the same variables. Here I have a 3x cubed. If I look over here at any of my other terms, do I have any other x cubes? No. So I'm going to rewrite 3x cubed here. My next term is a -2x squared. So I'm looking for x squareds. Do I have any other x squareds? Aha, I have one right here. So I have a -2 apples, and I am adding 4 apples. a negative 2x squared add 4x squared would give me a positive 2x squared. Okay, I'm just going to go along down the line and see if I have any more matches. Here I have the constant negative 6. Constants can only be added with other constants or subtracted with other constants. A negative 6, aha, here's another one, can only be added with this negative 7. So I'm in the hole, 6 apples. I'm going to go down. Someone's going to say, I'm taking away another 7 apples from you. So I'm in the hole, 13 apples. Now, if I look at my work so far, I've collected and I've combined everybody but this guy here. I haven't collected or combined him. He has nobody with the same last name of X. So what I'm going to do is I'm going to rewrite him at the bottom here. Negative 6x. When we rewrite our polynomials in a final answer, we always put the highest degree first. So that's the highest degree here. That was a 3. Yeah. So 3x to the third goes first. Then let's look and see, is there a degree 2 term? Yeah, right there. Plus 2x squared. Okay. And then we're going to look at who comes next. Aha, I have a degree 1 term. He's going to come next. And then lastly, I have my constant at the end, negative 13. When I add, all the signs stay the same. Now we're going to look at what happens when I subtract. Okay, when you see the subtraction sign, you need to tell yourself, stop. And whoa, okay? Stop. Whoa, stop, stop. I'll tell you that this little subtraction causes a lot of errors for students, and this tiny little subtraction creates a lot of frustration because students forget to apply it properly. So when you see that subtraction, you stop. Okay, that subtraction is like, think of it like a negative 1, okay? It's a negative 1. And this subtraction is going to apply to every term inside the parentheses. Okay? So I'm going to rewrite it. I've got a negative x cubed. Okay? And a negative is a positive 2x squared. Okay? And then, 2xy squared. And then I have this negative 1 and a positive times a positive 3y, and I have a negative 3y. Essentially, that negative will change all the signs. Okay? So when you see that negative, you need to tell yourself, stop, whoa, and change all the signs. I have to stop, whoa, and change all the signs. Okay? Kind of a goofy little rhythm there, but it's something important to remember. Okay, once I've applied that, it's like addition. Okay, remember that subtraction is the same as adding the opposite. So basically that's what I'm doing. I'm adding all of the opposite signs of my second parentheses. My first parentheses doesn't change. I have x to the fourth, and he's up front. And then second term in is 3x squared. Okay, 3xy squared minus 2y. Okay, so now we're going to look, since we're adding now, we're going to look at combining the same terms. So my first term I'm going to look at is x to the fourth. Do I have any other x to the fourth terms? I don't. So I'm going to rewrite them down here. Okay, let's look at my next term. My next term is the last name xy squared. So I'm going to look slowly. Do I have any other xy squared terms? Here I have one right here. So we're going to add these together. I have 3 apples and 2 apples gives me 5 apples. So 3 xy squareds plus 2 xy squareds gives me 5 xy squareds. Okay, all right. Now let's look. I have a negative 2 y. There's my last name of y. I need to look, can I find any other y terms? I sure have some right here. Okay, so I have negative 2y plus negative 3y. So I'm getting bigger in the negatives. Negative 2 and a negative 3 drop me down further to negative 5y. Now when I'm done with my problem, I need to look. Did I account for every term up there? No. This poor little fella got forgotten about. So what I'm going to do is I'm going to attach him at the end here. Okay, for my final answer, we want to make sure that we write our polynomial in such a way that the highest degree term goes first. So that would be this guy here. So our first term will be x to the fourth. And I have two terms here with a degree of 3. Okay, I'm going to put the x to the third term first, just because there's no y's in it. And then I have a minus 5x y squared. And then I have a, who's missing here? Mr. 5y, negative 5y. Okay, so there's my final answer, my final polynomial. Again, just a quick reminder, when you have a subtraction and you're subtracting two polynomials, you need to stop and whoa and change all the signs. You know what? A better way of saying it would be to stop, add, change all the signs. We stop, we put a plus sign, we change all the signs.